So what is a Spearman correlation? A Spearman correlation is used to determine the strength and direction of a relationship of the rankings of two ordinal or continuous variables. It's a bit more of a mouthful. We've got different things going on. You can use ordinal data or continuous data. Importantly, the Spearman correlation is a non-parametric test. It means it does not assume normality. The data do not have to meet that standard bell-shaped curve shape. And I've left you some other resources on the slide if you're trying to run this on your own and you're looking for a little more help. What are our assumptions for the Spearman correlation? We have 3 of them. The first is you need 2 ordinal, interval, or ratio variables, i.e. you need ordinal data or continuous data. You can have some categories here, or you can use continuous data. Our second assumption here is you must have paired observations. So for example, if I'm a participant in the study, I need something at time point 1 and time point 2, for example. I need to be measured twice. You can't match me with my best friend. It has to be me and me. And our third assumption is there should be a monotonic relationship between variables. Fancy way of saying the data roughly needs to be increasing or decreasing, not both. We'll cover these on the next few slides. Let's go. So checking our assumptions. Again, we're going to use fake data 1 and fake data 2. We've already determined it's got some decimal points. It's got a range of values. This data is continuous. We have passed this assumption. Our second assumption is we need to have paired observations. If we look across the rows, this looks like one person. This person identifies as male. We've got a fake data 1 and a fake data 2 variable for this person. So we say that this variable or this assumption also passes. And I'm going to shorthand our third thing a little bit, our monotonic relationship assumption. We've already made this plot by doing the Pearson correlation. So I'm just going to give you the plot. And we want to look at this plot critically and say, does it look like it's only increasing? Does it look like it's only decreasing? Or does it look like maybe it's increasing and decreasing? Does it have switchbacks? If I was to draw a line trying to touch as many of these points as possible, does it look like it's only going in one direction? Or does it look like it's moving around? And if we look at this, it looks like it might actually be decreasing for the first bit and then increasing for the second bit, which would mean this might not be considered a monotonic relationship. So we may or may not have passed this assumption, which is a reminder you always want to check your assumptions to say what can we do and what can we not do? What is statistically appropriate? What is not statistically appropriate? All right. To actually run the Spearman correlation, these steps should look familiar if you've just done the Pearson correlation. You click Analyze, Correlate, Bivariate. If you have passed all assumptions, you can move on to conducting the Spearman correlation. If you failed an assumption, the Spearman correlation might not be appropriate, or the result of the test might not be valid. If you're looking to run this on your own, Analyze, Correlate, Bivariate. We take our 2 continuous or ordinal variables from the left side. We click the blue arrow and put them in the box that says Variables. And then we want to make sure where it says correlation coefficients, we have checked the box that says Spearman. This will run a Spearman correlation. And then we click OK. If you have followed these steps, it will give you just one piece in your output. Again, you want to make sure if you're running this appropriately, you've got a much longer output. You've got all of your assumption checking and then the Spearman correlation at the bottom. So with our Spearman correlation, it gives us 3 main pieces in the output. It gives us our correlation coefficient, which for Spearman is called Spearman's rho. This tells you the strength and direction of the relationship. If it's a positive number, it means it's a positive relationship. As one thing is increasing, the other thing is increasing. If it's got a negative in front, it means it's a negative relationship. As one thing is increasing, the other thing is decreasing. A value closer to 1 is a strong relationship. A value closer to 0 is a weak relationship. Here we have a weak positive Spearman's rho. Our significance our significance row here is our p-value. A p-value less than 0.05 indicates a significant relationship between these 2 variables. A p-value greater than 0.05 we can't say whether there's a relationship between these variables. And as always, our n tells us about the number of observations we have used to calculate this. In this case, we've got 30. So again, we've got a weak, positive, non-significant relationship, and we've done this using a Spearman's correlation.